Welcome to our first example of continuous gameplay. Having reviewed the video that I produced for you to have a little bit of background on some simple calculus, we're now going to use that calculus to try to figure out what is the best price and quantity for Xavier and Yvonne to produce at their bistros. Now, these two people compete across the street from each other. Their cost per sandwich is the same, $8, and they're trying to maximize their profits. So what we have is a situation where they have determined the demand function from their customers. And the demand function depends largely upon the price of their competitor. So I have two different formulas here, and they're the same. So we're trying to keep it very simple. But in examples that I might give you on a test, these two equations might be different from each other. In this case, the quantity demanded for Xavier's sandwiches is equal to 44 minus 2 times his price plus the price of Yvonne. And of course, hers is the same thing. So what we want to do is construct a profit function. Now, profit, which is typically symbolized in economics by a pi sign, is equal to, very simply, total revenue minus total costs. And of course, total revenue is price times quantity, and total costs is cost times quantity. And I gave you the cost of $8. So another way to write this would be pi, or profit, is equal to the price minus 8, all times the quantity, which is 44 minus 2px plus py from above. If we then extend that, we can see that we get 44px minus 2px squared plus px times py minus 352, that's the 8 times the 44, plus 16px minus 8py, and then we can simplify that further by combining the 16px with the 44px and making it 60px. So we now have it simplified. Now, this is where our calculus comes in. What we want to do is simplify this, and calculus is the best way for us to do that. So we're going to take the first order derivative of profit with respect to px. And so let's look at our rules. So the equation from above, the 60px, using the addition rule, the 2px squared first becomes 4px squared, and then of course we subtract one of the px's from it, and we get minus 4px. And then the last piece of it is px py. We take out the px and we get the py. The other two components of the equation do not have a px in them, so we can eliminate them. And so we end up with this equation once we solve that equation for 0. Px equals 0.25 py plus 15. And of course, py equals 0.25 px plus 15. If we now take the equation for py and plug it in for the py on the left, we get px equals 0.25 times 0.25 px plus 15. And if we simplify that, we get px equals 0.0625 px plus 3.75 plus 15. And further simplification gives us 0.9375 px equals 18.75. And we divide both sides by the 0.9375, and we get px equals 20. And of course, py equals 20. So the price that the two bistros should charge is 20. And if we take that 20 and plug it into the demand function up at the top, we get qx equals 44 minus 40 plus 20 equals 24. And so the quantity of sandwiches, those being at 100 each, is 2,400 sandwiches per month for each bistro, and selling them at $20. So that gives them a $12 profit per sandwich, and they can make a nice profit doing that. So there's your step-by-step solution, starting with the demand function, which is typically what I will give you. And a lot of times I'll give you two different ones. And you're going to construct a profit function, and then you're going to solve that profit function down, and using simple calculus, you're going to get the price. And once you have the price for X and the price for Y, you can then plug those equations, the equation for PY into the equation for PX, and calculate the price and the quantity. And that's how it works. And this is how it works in its simplest form. So write this down step by step. You have open book tests. You will definitely have a problem. I'll be giving you one this week to work on over the weekend and turn in next week sometime. So write down the steps, make sure you understand them. Watch this video if necessary multiple times. Good luck.